Hello, my name is Nelson. This video is for the hands-on knowledge workers wanting to gain the additional analytical skills for building a great mission-critical system. Development was our 6th topics of this series. This is the 7th. In this short video, we shall uncover the secret sauce of testing and how we can use less time and less resources to produce better results. On January 28, 1986, a programmer missed one character in his C program. Instead of a double equals, he missed one equal sign and caused the entire space shuttle to blow up in mid-air, killing all 7 crew members on board and wasting billions of dollars. I would say testing is very important in a mission-critical system. The nature of software is we can have 99 things right, but if one of the major things is wrong, the whole program breaks. If we fail, don't give up, because fail means first attempt in learning. We as humans always make mistakes. We should forgive each other and most importantly, forgive ourselves. The following sections will be covered: an overview on the testing process, what are the testing levels, and what we want to achieve in testing, starting with the right attitude, how we can perform unit testing in less time with less resources and achieve better results. To get ready for deployment, systems integration testing, object code compilation, and user acceptance testing are all needed. Majority of the testing will be and should be done at the unit testing level. After that, systems integration testing is required to make sure that the entire system runs smoothly with relevant components and other systems connected. It is an iterative process. Any error found will cause the source code to be redeveloped for further testing. After that, we need to compile the source code into object code and deploy to another server in order to conduct user acceptance testing, or in short, UAT. UAT is meant to impress users, not meant to find error. However, if an error was found at this level, there is a lot more work involved, as you can see from the 5 additional steps taken. That is, redevelop the source code, perform unit testing, systems integration testing, compiled into object code, and deploy to UAT server all over again. Now imagine finding an error on a production system. Therefore, there is huge savings to find error early in the testing cycle, and that's what this video is all about. We have left out regression testing from the previous diagram on purpose. Changes can affect other areas within the application. It is not uncommon for an inexperienced developer to create many bugs on each change made to the system. Regression means retesting the unchanged part of the application, and it can be costly. Those many attempts have been made to automate this. It is only as good as the testing programs written. That is, who is going to test those testing programs? Via drag and drop, Rintagi knows ahead of time what areas will be affected and generate the appropriate code for most of the changes, so no testing is required. For the 10% custom business rules, we will introduce impact analysis on change management in the next video to avoid the need of regression testing. Unit testing is to make sure individual parts are correct in terms of requirements and functionality. In my opinion, this is the most important step, as it enables us to do the right things right the first time. Systems integration testing is to make sure the application as a whole meets the specified quality standards, especially if other components or systems are involved. User acceptance testing is the last stage of testing before deployment. It is conducted on another server and in conjunction with users, test against pre-written scenarios and test cases until satisfied. It may involve parallel run. What do we want to achieve in testing? Testing can be functional or non-functional. Non-functional testing such as security, permission, and portability are taken care of by Rintagi automatically. Performance, load testing, stress testing, user interface, and user experience are further taken care of by Rintagi's drag and drop development. Functional testing takes the most time. It is done to ensure systems compliance with its requirements on input data, data storage, and output data. The secret sauce of testing is repetition. Every time we go over the same thing again, we uncover something. We should stop only when we cannot uncover more. Should we be happy when we find our own bugs? We should, or we will try everything to avoid it, consciously or subconsciously. That's just human nature. We seek happiness all the time. Human is born with defensive mechanism. Even the most notorious criminals would not admit that they were wrong, so why would we attack our own design or program? The key is to make it interesting. Think of it as a crime scene investigation or audit. The following attitude is recommended. When something is wrong, the first thing to pop into our mind should be, I could be wrong. We should have no compromise on quality and always enjoy a challenge. Have a strong desire to find and fix our own bugs, so nobody else would know about it. Understand that repetition is key to perfection. Go over the use case scenarios as many times as we can to uncover missing cases. Now that we have the right attitude, let's talk about management. Would we rather spend the time checking on every single thing other people do for us? Or would we rather have the peace of mind knowing that they always do the right things right? The choice is obvious. There are two ways to manage testing. The old way of assuming mediocrity. Build a hierarchy of testers to serve programmers and worse, one another. It is expensive, time-consuming, and often frustrating. Or the new way of empowering developers with testing skills and employ automated development platforms such as Rintagi, so everything is done right the first time without extensive testing. Therefore, no tester is required. We use less time and less resources to produce better results. What a pleasant experience. In line with the previous recommendation, there are two approaches to testing. The old way of preparing the test cases after the system is built, that is, the developer has no idea what the system will be tested on. It is expensive, time-consuming, and often frustrating experience. Or the new way of training the developers to develop those test cases ahead of time, so it can be done right the first time. It is a straightforward and more pleasant experience. What to test first? System is designed for one and only one purpose, the output. Therefore, we should verify the output data and reports first so that data model, transformation, business rules, etc. can be validated. Enter comprehensive test data directly and manually for each test case to begin output testing. Based on each of the user scenarios from systems analysis, expand them into comprehensive test cases in data modeling. Each test case should, at the very least, specify the following: preconditions before executing the test, if any, the test data, expected outcome, the actual result, and the test status. The actual results must be consistent with the expected results before we stop testing. It can be further enhanced by adding reference and purpose. This is an example test case where customer ID equal to 55 and the product ID equal to 100. The expected price is a unique special price of $77. The actual result is the same as the expected. Therefore, the status is okay. Note that the product ID can be null to imply all products. This is another example test case where customer ID equal to 66 and the product ID equal to 200. Neither of them can be found here. The precondition is price sheet ID 1 is marked as base price. Since this customer does not have a unique special price as indicated on the bottom right, and there is no price sheet assigned to this customer as indicated on the bottom left, the expected price should be the base price ID equal to 1 according to the algorithm we derived from previous data modeling. However, the base price product ID is 100, therefore the actual result is not found. There is a choice to change the product ID to null so that all product is now $92 for the base price. We can test again, and the actual result is $92, which is the same as the expected result, and the test is now concluded. After the output is verified, prepare test cases for input data entry screens. For every actionable items on each screen, ask this question: what should or should not be done? Keep testing if any of the actionable items are missing. Validate the output again using new data entered via these screens. Test iteratively and incrementally. Repeat until satisfied. Then pass on to systems integration testing. To get ready for deployment, we need to perform systems integration testing. Here we enter real data via input screen, walk through every possible use case scenarios, including all relative systems and components. Verify expected output for all possible test cases. Postpone testing and fix each problem as soon as found, especially on major issues. Repeat until satisfied. Production system requires the source code to be compiled into object code, so the subsequent system can run at its optimal speed. Similar to user acceptance testing or UAT, production system needs to be installed onto another server. However, in a non-mission critical environment, we can turn the UAT server into production server simply by refreshing the data. This Rintagi interface enables a deployment package to be prepared, compiled into object code, and download as one executable file. When this deployment package is executed, we would first deploy it to a UAT server to conduct user acceptance testing. Only when users are satisfied, we will use this same interface to deploy to a production system. The following is the typical to-do list for user acceptance testing. Demo with live data and walk through as many test scenarios with users as possible. Give users a checklist for all scenarios. Encourage users to test on their own. If possible, perform parallel run, matching output from the legacy system. Rectify as soon as an error is found. Perform change on the fly in front of the users if and when possible. Repeat until users are satisfied. These are the takeaways. Testing is about fully understand the business requirements. Keep asking, how do I know I have done the right things right? Exhausting all possible user scenarios. Verification by comprehensive test data. Using an automated platform such as Rintagi to reduce testing requirements. The relentless practice of repetition on testing. These are the references for further reading. Thank you for watching. In the next video, we shall see how deployment is done and evaluate the many deployment options and their pros and cons.